In this lecture of integration, we will perform the integration of root over 1 plus cos 2x, root over 1 minus cos 2x, and root over 1 minus sin 2x. At first, we will perform the integration of root over 1 plus cos 2x with respect to x. In order to perform the integration of root over 1 plus cos 2x with respect to x, we can write y is equal to integration of root over 1 plus cos 2x into dx. Now, according to the trigonometry, we know that 1 plus cos 2x is equal to 2 cos square x. If we put this value of 2 cos square x in the place of 1 plus cos 2x in the integration, then the integration will look like y is equal to integration of root over 2 cos square x dx. Now, as this 2 is constant, we can separate this 2 out of the integration, and integration will look like y is equal to root 2 into integration of root over cos square x dx, which can be simplified as y is equal to root 2 integration of cos x dx. Now, this integration of cos x will result in sin x. So, finally, the result of integration y is equal to root 2 sin x plus the integration constant c. Next, we will perform the integration of root over 1 minus cos 2x. Again, in order to perform the integration of root over 1 minus cos 2x with respect to x, we can write y is equal to integration of root over 1 minus cos 2x into dx. Again, according to the trigonometry, 1 minus cos 2x is equal to 2 sin square x. If we put the value of 1 minus cos 2x or 2 sin square x in the integration, then the integration will look like y is equal to integration of root over 2 sin square x dx. Now, we can separate these two, then the integration will look like y is equal to root 2 into integration of root over sin square x dx, which can be simplified as y is equal to root 2 integration of sin x dx. This integration of sin x dx will result in minus cos x. So, finally, the result of integration is y is equal to minus root 2 cos x plus the integration constant c. Now, next we will perform the integration of root over 1 minus sin 2x. In order to perform the integration of root over 1 minus sin 2x, we can write y is equal to integration of root over 1 minus sin 2x into dx. Now, according to the trigonometry, sin 2x is equal to 2 sin x cos x. If we put this value of sin 2x or 2 sin x cos x in the integration, then the integration will look like y is equal to integration of root over 1 minus 2 sin x cos x into dx. Now, this 1 can be written as sin square x plus cos square x. Then the integration will look like y is equal to integration of root over sin square x plus cos square x minus 2 sin x cos x into dx. Now, this sin square x plus cos square x minus 2 sin x cos x will be fall under the formula of sin x minus cos x whole square. Then we can write y is equal to integration of root over sin x minus cos x whole square into dx. So, finally, integration will look like y is equal to integration of sin x minus cos x into dx. We can separate the integration as y is equal to integration of sin x into dx minus integration of cos x into dx. Integration of sin x will result in minus cos x, and integration of cos x will result in sin x. So, finally, the value of integration y is equal to minus cos x minus sin x plus the integration constant c. This can be simplified by taking minus common, or y is equal to minus cos x plus sin x plus the integration constant c. This concludes our discussion for this lecture. In the event that you have any question regarding this presentation, feel free to post them in the comment section, and don't forget to hit the subscribe button. See you in the next one.